Welcome to a new episode.
Hello and welcome back to the Copper Connection podcast. As always, I'm your host Chris Bailey and this is episode 18. If you're joining us for the first time, welcome. The Copper Connection podcast is your go-to resource for all things construction, design and building practices. Today we are diving into part 2 of our Building Principles series. In the last episode we covered the fundamentals, and today we're diving deep into the practices, considerations the architects and designers and the construction professionals need to think about when bringing a building project to life. We'll be exploring everything from aesthetics and buildability to modern construction methods, building regulations and even working with heritage buildings. Whether you're a student, a professional in the industry or just someone fascinated about how buildings come together, this episode is packed with valuable insights. So grab a coffee, settle in and let's get connected. So let's start by setting the scene. Section 1. Key factors in design. Let's start by setting the scene. When designing any building, there are numerous factors that need careful consideration. We're talking about aesthetics, buildability, construction methods, inclusivity and accessibility, regulations, restrictions and planning requirements. It's quite the juggling act. But here's something really important. When we're talking about national infrastructure projects, there are 4 key considerations that guide the design process. First, we have climate. Any infrastructure must help the UK achieve net zero greenhouse emissions by 2050 or sooner. And it needs to be able to adapt to climate change. This isn't just a nice to have anymore, it is essential. Second, we have people. Projects should be human scale and instinctive to use. They should seek opportunities to improve the quality of life for people who live or work nearby. After all, buildings are for people. Third, we have places. Schemes should provide a sense of identity for communities, supporting both the natural and built environment while enriching ecosystems. And finally, value. Infrastructure should add value beyond its main purpose, solving problems well and achieving multiple benefits. It's about getting the most out of every project. These principles really set out the foundations for thoughtful, sustainable design. Section 2. Aesthetics and buildability. Now, let's talk about aesthetics, because let's face it, we all want buildings to look good. There are several factors that affect the design of a building or structure. Colour is a big one. That's about the use of various materials and shades: block, stone, glass, UPVC, cladding, steel. Each brings its own character. Then there's shape. The patterns or lines of brickwork, cladding, glass and steel frameworks. These create visual interest and define the building's personality. Texture is another consideration. Materials have different textures, from rough cut stone to polished concrete, from rough sawn timber to dressed timber, and from textured to smooth paint finishes. Location can affect the choice of materials selected to blend into the environment. And don't forget about planning. Local authorities may actually stipulate that materials used as part of the agreement. But here's the thing. A design must look fantastic on paper, but can it actually be built? This is where buildability comes in. Buildability is defined as the extent of which the design of the building facilitates ease of construction, subject to the overall requirements for the completed building. It's about making for a quick, cost-effective and productive outcome. A beautiful design that can't be built effectively is just a pretty picture. Section 3. Traditional versus modern construction methods. This is where things really get interesting. Despite all the advantages in construction technology and the urgent need to improve building practices, many companies are still sticking to the traditional, tried and tested methods. Traditional methods include on-site brick and block external wall construction, in situ roof erection, traditional plastering, working from architect's drawings, and using subcontractors for specific tasks. Now, there are advantages to this approach. It's how many tradespeople were trained. It doesn't require additional sale fees, and there's no expensive upfront investment. But the disadvantages: increasing wastage of materials, missed deadlines due to bad weather, and missed deadlines due to the lack of personnel at key times. These are significant issues in today's fast-paced construction environment. So what are the modern alternatives? We have prefabricated flat pack systems are gaining popularity. Wall and floor panels are fabricated off-site in a workshop, ready to be jointed on-site. This can include surfaces, windows, doors, and even decorative finishes. We then have thin joint masonry. Uses just 3mm of mortar instead of the traditional 10mm, which cures much faster. The blocks are twice the size of traditional blocks, allowing for a greater area to be constructed in less time. We have pre-cast foundations. These are cast in a factory to the client's specification and fitted to piles on site. They require less excavation and aren't as weather dependent, allowing for greater productivity. Let me give you some specific comparisons. With roofs, traditional methods mean site carpentry working at height for the full duration of the task. Modern methods, the roof is constructed at ground level and lifted onto the structure, meaning limited time working at height. That's a huge safety improvement. For block work, traditional methods require 10mm of mortar, which takes time to cure, resulting in fewer courses being laid in a day. The modern thin joint system dries quicker, requires no pointing, so more courses can be laid in a day. And plastering versus dry lining. Traditional plastering uses large quantities of water and takes time to dry out. With dry lining, plasterboards are dot and dabbed onto the walls, joints are taped and jointed. Very little water is used, so the moisture content of the building is vastly reduced, along with the drying times. Section 4. Innovation Construction Methods. Let's look at some more innovative approaches. Prefabricated modular construction is fabricated in a factory away from its final location. It's cost effective because it's built in a controlled environment and normally using sustainable materials with improved thermal and acoustic installation levels. All doors, windows and surfaces can be pre-fitted, reducing waste because of the working environment is consistent. It's often designed using BIM, building information modelling, so surfaces are planned into the design from the outset. Work can be carried out year-round and issues are addressed prior to site delivery. This is an absolute game changer. Timber frame construction. It isn't new, it's been around for centuries, but with modern materials, insulation and working practices, timber frame properties have become more sustainable alternative to brick-built homes. They have better thermal performance than masonry with a thinner wall thickness. And there's structural insulated panels, or SIPs. They are fabricated in a factory environment, sharing the same benefits as modular construction. SIPs arrive on site as a flat pack and are fitted together to form the main structure, then fitted out with surfaces once the structure is watertight. It's like building with giant Lego bricks. Section 5. RIB Plan of Work. Now, how do we organise all of this? The Royal Institute of British Architects, the RIBA, have created a plan of works designed to offer a comprehensive framework for successful organising a planning project. The plan organises the process of briefing, design, construction and operating building projects into 8 stages. Stage 0, strategic definition. Stage 1, preparing and briefing. Stage 2, concept design. Stage 3, coordination. Stage 4, technical design. Stage 5, manufacturing and construction. Stage 6 is the handover. And stage 7 is the use of the building. At each stage, the plan defines the stage outcomes, core tasks, core statutory processes like building and planning regulations, procurement routes, and information exchanges. It's a roadmap that keeps everyone on the same page throughout the project lifecycle. Section 6, Sustainability and Building Regulations. Let's talk about sustainability. At the design stage, considering the life cycle of a building, looking beyond construction to how building is occupied and used, and what happens when it's reached the end of its useful life. The longevity and sustainability of a building is crucial. The industry works to reduce its environmental impact. Early considerations of the building's life cycle can also improve cost efficiency. This involves analysing the carbon emissions of a building over time and considering how these can be reduced. For example, by ensuring the building uses heat and light effectively. Now, all buildings and adaptations to existing buildings must meet the current building regulations. These comprise of several approved documents, each covering a specific area, from Part A through to Part R, plus approved document 7. The building regulations are intended to protect the end users' safety, health and welfare in and around the buildings. They're also designed to improve the conservation of fuel and power, protect and enhance the environment and promote sustainable development. These cover everything from structural safety and fire safety to ventilation, drainage, electrical safety, security, and even physical infrastructure for high-speed economic communication networks. It's comprehensive. One particular important document is Approved Document M, which outlines accessibility and inclusivity. This covers ease of access and the use of buildings, including facilities for disabled visitors or occupants, and the ability to move around the building easily. It provides guidance on ramps, steps, wheelchair accessibility facilities, and the construction of accessibility stairs and corridors. Inclusive design isn't optional now, it is truly essential. Section 7, Heritage Buildings and Local Restrictions. Finally, let's touch on something really special. Heritage buildings. These are buildings of historical and cultural importance to the community, and often listed buildings. There are 3 grades. We have Grade 1 buildings, are of exceptional interest of the highest significance. Grade 2 buildings are special interests warranting every effort to preserve them. And Grade 2 star buildings are particularly important buildings of more than special interest. The listed buildings and conservation areas Act 1990 covers legislation for these buildings. And here's a serious part. Breaches to the legislation or damage caused can lead to fines or court's orders stipulating that all work is undone and the building is returned to its original state. Listed building consent is needed before you can work on any listed building. This consent is in additional to any planning restrictions or regulations that normally apply, and permissions can only be granted by the local planning authority or the Secretary of State. And don't forget about local authority restrictions. A style of home or design feature that might be accessible in one area might not be acceptable in another, even within the same local authority boundaries. Local planning ensures that buildings fit harmoniously within their communities. Okay, and that brings us to the end of episode 18. We have covered a lot of ground today, from the key factors of design and the evolution from traditional to modern construction methods, to the RIBA plan of works, building regulations and special considerations for heritage buildings. The world of construction design is consistently evolving, balancing aesthetics with functionality, tradition with innovation, and always keeping sustainability and accessibility at the forefront. If you've enjoyed this episode today, please subscribe to the Copy Connection podcast wherever you get your podcast from. share it with your colleagues, classmates, or anyone interested in the built environment. And if you have any questions or topics you'd like us to cover in future episodes, please reach out to us at the copyconnectionpodcast@gmail.com. Thank you so much for tuning in. Until next time, keep building, keep learning, and stay connected. This is the Copy Connection Podcast, and we will see you next time.
We'll be back next week. In the meantime, please subscribe and thanks for listening.